So good morning, good evening, good afternoon, depending on where you are. We will start today with looking at some of the stuff for, I believe this is also OpenTelemetry related, Tarek, right?
Yes.
Do you want to talk about it?
Yes. So to give a quick background, what we are trying to do here is we already exposed the classes called activity source, which has a method is called the start activity, as you see the signature in front of you. So start activity is just the ways that you can create and start a new activity object. And this method takes some parameters like, activity kind, activity context, and so on. And if there is any listener listening to the activity creation events, they will get called back. I mean, they will be notified, and when it get notified, we will send all these parameters that pass to start the activity method to the listener. The way we do that, I mean, if you see in the screen the delegate definition declaration there, this is the callback that the listener will have. So basically, this delegate is taking a parameters, which is a reference to struct. This struct is called the activity creation options. And this struct actually is just wrapping the parameters that we pass to start activity. And the listener is free to look at all these parameters and at the end decide if we really need to create the activity object or just don't create it. I mean, so notify us back telling like, yeah, I'm interested to create the activity, or I'm not interested. So, and according to decision of the listener, we create the activity or we don't create it. Recently, we ran into a new scenario with OpenTelemetry that the listener, which is in the OpenTelemetry is a sampler, is actually not only want to get the parameters that pass to start activity to decide about the activity, but also need to add extra stuff to the activity. So like extra tags to the activity. And in current design, I mean, there is no way that they can communicate extra data or extra stuff that we can pass it to us. So when we create the activity, we add this data to the activity object. So the proposal here is the struct activity creation options that we pass to the listener. Today it's read only. So we are going to change that to be a read write struct and we'll add extra properties that they can add the tags that they need to. I mean, the listener can add the tags to the while it get called back. So it can communicate us the extra stuff. So if you go a little bit down, Yemo. Yeah, so the first part of the proposal here is this is the activity creation option. So it used to be read only. So we are changing that to be not read only. And we adding the first property here is called sampling tags, which is this is a property that it has just getter. So we are internally about like if somebody calls this property, if internally the collection, I mean activity tags collection is not created yet, we will create one and return it back from the getter. And if it is already created before, so we return whatever created. So this way we will have a way that to give the listener the way that gives them this instance of this collection so they can stick extra tag to it. And after that, we can use this tag and add these tags to the activity object when it gets created. So before I go to further than that, I mean, like I want to see if there is any feedback about this part before we continue.
My only question is when you remove the read-only specifier from the type, what does it actually mean for C#? It wasn't there the idea that if you do that, it avoids defensive struct copies, but now when you remove that, it will impact other things as well, where the compiler now may actually perform defensive struct copies?
Actually, we are passing this by reference anyway in the delegate signature. So I don't think this will add any different. I mean, it will not affect the perf, I believe.
Yeah, I was also curious for like when you invoke instance methods, for example, like that the compiler doesn't know that the instance method doesn't mutate the struct, right? So it isn't there often a defensive copy being made. So even if you pass the struct itself, as soon as you invoke any sort of methods on the thing,
Mm-hmm.
I mean, if it's coming literally
don't
from a
think that'll
ref,
happen if it's a ref.
yeah, if
That
it's
would only
if you
happen if it's
yeah, if you're not a
non-ref.
ref, yeah, I mean, if you're yeah, yeah. Basically, my question is just like, what does it actually mean? Are there any?
We can certainly go double check in the the generated IL for the little snippet of code where it's going to get used.
Well, is this even a place where we care about micro optimizations like that?
It is actually. We do care
Okay.
that this is pretty fast.
Yeah, I mean, like, I guess my question is more broad because so far I've not seen in an API review where somebody removed the read-only specifier. Usually we add them, so I'm just wondering like what the implications are of removing it.
So the language itself doesn't consider it a breaking change. Last time I talked to Jared, it is a potential behavioral change, however, in that if you have an assembly that was compiled against a ref assembly that had the read-only specifier, and then you remove the read-only specifier, and then you rerun, you can potentially see mutations where you wouldn't have previously.
Well, there's that too.
Does this happen even with the ref? I mean, if you're passing the struct with ref?
And we did only, like, this struct didn't exist before .NET 5. So this is just a preview to preview change.
Ah, gotcha. So we haven't. Yeah, I mean that was my other question because you suggested to remove some things from the type as well. But yeah, I mean, I guess from my point of view, like even if you haven't shipped the type, it's just a question of like, okay, we previously had it read only, now we don't have it. Regardless of the breaking change, I'm just curious what that actually means in terms of perf for the other existing properties and methods on it. I mean, the reason you're doing it is basically because you want sampling text to be lazy, right?
Yes.
Yeah.
So you can have it be read-only and use compiler tricks and unsafe code to lazily initialize it, and as far as the compiler is concerned, that is still read-only because it is observably the same as read-only.
Yeah, I wouldn't do that because like I'm expecting in the future we will add more to this struct and we don't need to have this restriction at that time.
I mean, in general, we don't want mutable structs, right? So like the thing is, in principle, all structs should be read-only because mutable structs are, generally speaking, a bug farm. If things are mutated for lazy initialization, as Tanner said, that is by and large unobservable to if you do it correctly for the consumer. So it shouldn't matter that you mutate the struct. In which case, you probably get away with lying with the unsafe methods that we have. But if you suggest to add other things that are actually mutable, I would generally not be super keen on doing that because that usually creates problems. We have done it in the past for certain things like value value tuple, right? Where it was just cheaper to do fields, in which case it's hard to, not make them mutable. But like the thing is, it kind of, just keep this in mind. So like, it's another option, right? You could decide to just leave read only on it and just lie in the initializer.
Yeah, which is, if you're only doing lazy initialization, that's likely better anyways. Just from the perspective of if someone does pass it via in and then call the getter, they're going to get a hidden copy because it thinks the struct's mutable, and because you're doing normal initialization which means that the get method won't be marked read-only itself, because there are also partially immutable structs, in which case you can mark individual methods as read-only. And if you call those particular methods from something that was passed by in, or which is itself a static read-only, there won't be a copy made. So if you do have the concern that you might expand things in the future to have setters and you want it mutable, you could have the individual get-only methods be marked read-only.
Yeah, got it.
And then do the unsafe lazy initialization trick behind the scenes so that the compiler allows you to mark it read-only because it is functionally read-only.
Got it. Okay. So what is the suggestion here now?
I mean, I would say I would probably leave the read-only modifier on it and just lie if the only reason is you do it for lazy initialization. And then if you're growing that set, then I think if there's more things we can talk about, whether that's a good idea, and if we believe, then we just can later on remove the read-only modifier still. Like, I mean...
Okay. And is it, I'm not sure about like if we can mark the struct read-only and the getter will be lazy initialization. I mean, like, so C# compiler is okay with that? I'm not sure.
So if you do that, you have to use unsafe code or the system runtime compiler services unsafe class to write the backing field without the C# compiler seeing as an assignment. It is completely valid to do so, provided you're doing it within a the standard lazy initialization pattern, in that if it's null effectively or undefined, you set the value, because then it's functionally read-only. That is, no observer will ever see the uninitialized value.
Okay.
And then after it's been set, it won't be changed again.
Okay. So now, do you see any concern to have the struct read-only again?
No, I mean, that is exactly what we're doing. We're just doing lazy initialization for performance.
Yeah, I'm talking about like in the future, just in case.
I mean, to me, worst case, I mean, we originally had discussed having a second struct on the thing where we were going to put the mutable stuff. So I would think worst case in the future, if we found some things that really needed to be mutable, we could again add the second struct that was mutable. Well,
it should be completely legal to mark the struct as read-only today. And if you decide to add a mutable field in the future, remove the read-only from the struct. Add read-only explicitly to every existing property, and then make the new thing immutable. That will ensure the existing compiled code will have the same behavior, and new compiled code will also have the same behavior due to the explicit read-onliness on the method.
Okay. This sounds good to me.
Yeah, it sounds good to me.
I had an additional question about this property. Are we sure that tags is the only thing that we would want to add to activity? Like, are we going to put more activity members here?
In the future, it's possible to add more, yes.
Okay, so did we consider a callback that would say, hey, if you want to modify newly created activity, here it is, instead of copying these members to activity creation options? So sampler would be called twice, once to know if it wants the activity, and the second time for it to populate the activity with the things it wants to put there. Because I don't want to end up in the place where we have two things that are basically activity and one of them is struct and like this kind of mess.
But this means that, I mean, the caller, I mean, the listener has to match about like which activity really, I mean, matching which part.
I mean, we'll pass the entire activity creation options along with the newly created activity. So like the information they wanted to get from activity creation options to put onto the activity, they can still do it. Because like when do we stop copying things from activity and putting it here?
So you mean now about this way? I mean, the listener will get the callback. I mean, they have to handle 2 callbacks instead of 1, right?
Right. But
which is you don't see this is concern for perf either?
I see more concern about like this type having sampling tags and then sampling attributes and then sampling status and then like all activity properties being copied on the activity creation options. I see that as a bigger problem because not every sampler would need to modify the activity, but everyone would pay complexity and the cost of like allocating this struct that's getting bigger and bigger and bigger.
I mean, it's kind of like, it seems like your struct becomes effectively the builder for the activity, right? In which case, builders and non-builders always have this weird thing where they duplicate each other, right? Which is unfortunate. But if you get away with a callback, because it's rare to modify it, it's probably less complexity, right? Because basically at that point, anything that you could change an activity is now fair game.
Yeah. I mean, while we're discussing alternatives, I mean, the other thing that it's a little sleazy, but effectively, if you stored whatever you wanted to store it in a thread local, you know that the next start callback from this listener is going to be the activity that was just created. So that's a sleazy way you could achieve the same thing without even storing a delegate. I mean, the first thing that comes to mind when I think of the delegate approach is now, of course, you do need some sort of setter on this creation options, or you need to change the signature of the change the signature of the sample method to return the delegate, and then the enumeration that it's returning right now needs to be somewhere else, or maybe you have a structure where you're returning a delegate and a enumeration. It would fiddle with this thing a bit.
I think bubbles means that adding extra callback to the listener doesn't have to be returned from here, right?
Oh, okay. Maybe
Yep. It would be side by side to should create callback.
Yeah.
Like it would be should create and then populate 2 side by side callbacks that get executed one after another, and they're somewhat independent.
I mean, it raises the other question, like, would the should method ever have to access state that only gets populated after to make the decision? Or is this basically the same party?
Let's get back to a use case that OpenTelemetry has. What are we solving? Like by adding this API, what are we trying to support?
OpenTelemetry says that samplers are allowed to add tags. This is taking that requirement fairly literally, just saying, okay, if samplers are allowed to add tags, then here's a collection where they can stick their extra tags.
Do we have an actual scenario for that, or are we just preloading?
I can give a scenario. Yeah, I think it would be mostly useful for attaching the sampling weightage to the individual item if the sampler wants to.
So would the sampler be able to calculate the same value if it got the second callback?
I am not sure of that unless it has a way to remember the state from the previous.
What would be a typical way of calculating this value, or if you know?
Yeah, I'm not very sure, but like in previously in application sets, what we use is the probability. If it's a probability based sampler and we are only, let's say, taking 10% of the items, and we'll attach like a weightage of 10 to each individual item to represent that it is in fact carrying like 10 weight as opposed to a single. So only the sampler knows what is its current percentage of things being sampled in. So it has to attach that to the activity itself, so that at some other place we know this activity is not just one, it's somewhat representing more than that. So this is just a use case.
Okay, thank you. Does the spec say that the sampler is able to modify more things than just tags?
No, just tags, because this is only for deciding whether the activity itself should be created. If one wants to enrich the activity further, we have more callbacks like onStarted and onEntered, where we can do more things. But this is like very specific. This decides whether the activity itself should be created or not. And in OpenTelemetry, we use it to plug in our sampler logic, and like there is a specific requirement that sampler can attach things to the tags, and that tags should be part of the activity should it be created.
Okay, so I think if we say tags are the only thing that is getting attached, and we won't try and grow this type into builder, and like you cannot recalculate the same set of tags in the second callback, this might be fine. The other option is returning not just an enum value from the sampler, but like a struct that contains enum value and other things. But yeah, I think it seems like having a second callback doesn't actually solve the problem at hand.
Yeah, so the second callback, it's another option. We can do it in the future if we need to. I mean, like if this is going to grow more, we can provide at that time the second callback, and it will solve the issues.
I mean, my other thought would just be, even if we did add a little bit more to this struct in the future, I think the main cost that we're paying is the cost to initialize the struct field to null before we pass it, which I would hope is not all that expensive.
Sure.
I mean, certainly it has some cost, but I would think it's a pretty small one. You know, like initialize another field or another 2 fields to null before passing. Because I mean, we're passing the struct by reference, so that the pass shouldn't be any more expensive. And if none of the code actually uses those fields, then there's no cost incurred to having them sit there and stay null.
Definitely. What I'm worried about is having the entire activity. The entire activity ending up there because we wanted to change all the fields.
Right.
Like then it's just a bad API design, right? To have 2 copies of activity, not like even not taking perf into consideration.
Sure.
So the conclusion then is we leave the design as proposed, having the struct with this sampling tags as opposed to having a callback.
That's what it sounded like to me.
Yeah, just keep it read-only and do the crazy stuff.
And then I guess we should talk about the sort of the second proposed part that's riding along in the wake.
Yeah, the other part. Yeah, just keep the screen. Sorry, there is other part here.
Oh, sorry.
So yeah, so. Previously, we have also exposed a property on the activity listener itself. It's called auto-generate root context trace ID. I'm not sure if you remember this in previous reviews. And this property was intentionally, I mean, like trying to have the listener to a way to tell us to auto-generate trace ID if we have a root context. And this is proving it's not easy to understand and how to use it. And we got some feedbacks like, you know, it's not easy to use and not clear about how you are going to use it or so on. After we decided about the struct that we are adding extra stuff on the struct, so we decided to remove this property from the activity listener, and instead of having this property, we will have on the struct itself activity creation options. We will have another property. It's called trace ID. Yeah.
Gotcha.
Yeah. So trace ID is the way that like if we already have non-root context, so trace ID will return this non-root context. But if we have a root context at that time, we will auto-generate a trace ID for it and return it back to you. So this will just go ahead.
I just said lazily.
Lazily, yes.
Yeah. Like the whole point of the old thing was so we could be lazy, so we can still be lazy.
Question.
Yes.
Why don't we generate the entire new activity context and don't add any new property? Like we have a listener overload that takes activity context. So why don't we create that?
That's the parent context.
I see, and this is what would be used for this activity.
Yeah, this is So the parent context is still it's still default. I mean, it's a struct. But the parent, there is no parent, so the parent context is default. This is just saying this is the proposed trace ID for the new activity you're creating, which has no parent.
Should we adjust the name? Because now we have the property with the same name on this object and on the nested object. And I mean, I get confused, but it's not new, but
right.
But
do you have an alternative that seems less?
Prefix it with something like proposed, auto-generated, new, whatever.
Not generated actually, because it could. If you don't have a default parent, trace ID would return this non-default parent at that time. Trace ID.
Wait, so it does sometimes return a parent, and sometimes it is what you are gonna be.
Mm-hmm.
That's
well, it's always what you're going to be. It's just to say the algorithm for what you're going to be. If there's a parent, it matches the parent. But if there's no parent, we create it from scratch.
Right.
But
okay, I see. So it is the same value basically, if the parent is there.
If the parent is there, it's the same value. But semantically, it's always the trace ID that will be set on the activity that you're about to create. I mean, if proposed is clearer, that's fine with me. I sort of think of this entire structure is sort of implicitly what's like these are the creation options for the thing you're about to create. It's just one is the parent context and the other one is the trace ID of the activity you're about to create.
Question. Activity context in the callback is not nullable. So how do we expect people... It
can be default.
Yeah. So do we expect people to compare it with default to know that there is no parent or?
Sure. Or they might just compare a part of it. Like they might just look at the, just the span ID or something. But effectively, yes, they just check it to see if it's default.
Okay. I'm fine with trace ID then. Like if the parent is there and it's the same value, then it's less confusing than I thought.
Okay. Any more feedback before we move on?
That seems fine to me too.
Okay. So let's go. So the rest of the changes here is just renaming some methods and renaming some stuff. I mean, because like the naming also, we got a feedback from the OpenTelemetry community about the naming. And it's kind of like trying to use the right terms now more than what we had, because what we had it's a little bit confusing for them. So basically, if you look at this, so if you look at the delegate who's returning activity data requests, so we renamed this enum activity data request to called activity sampling results instead. And we have renamed the name of the delegate itself from get request data to sample activity. So this is first part. Second part is we renamed the two callbacks methods that get passed to the listener. One of them is called get requested data using parent ID, and get requested data using context. It was renamed to sample and sample using parent ID. So this became much simpler and matching the scenarios that we are targeting.
Do we still need sample using parent ID? Like if you're moving a lot of stuff on the main
so-
activity request, why do we still need the separate sampling method?
So parent ID handles this historical case where you're using the hierarchical IDs instead of the W3C IDs. It's not expected to be commonly used, and we've already put something in place where you don't even need to implement that callback, and we'll automatically, if your ID is of the W3C format, we'll just parse it for you into the activity context. So the only case where you ever need to put anything in that field is if you know that you're going to be sampling hierarchical IDs.
Okay. So, okay.
So
It looks sufficiently scary then to dissuade me from assigning to it.
yeah, I mean, and I hope we'll, stick something in the comment that's sort of like, you only need to bother with this if you care about hierarchical IDs, which I assume most people or nearly everyone doesn't need to worry about.
Okay. So
Thank you.
go ahead.
Oh, I said thank you.
Okay. Yeah. So I think that's all we have. I mean, if there is any more feedback about that.
So you're also renaming activity data request to activity sampling result, correct?
Yeah.
And then you also renamed get requested data to sample activity, right? So they are not listed here, right? So I'm only asking because it's the diff that I have here seems inconsistent or incomplete.
What's
No, I think they're all there.
So the return types haven't been renamed, they're just different types. Both already exist.
Wait, where are you looking?
So basically, this is current, right?
Yes.
Yes.
This is new.
And this is yes.
Yep.
So I assume this method or this delegate got renamed from this to this.
That's
Correct.
right.
And I
Yes.
assume this return type got renamed from this to this.
That's right.
Correct.
And then same thing here, like this property got renamed, right? And then this
Right.
guy got renamed to this, I suppose, right?
Yep.
Yes.
Yep.
That's right. So that's all. Yes.
All right. No, makes sense to me. Any-
Great.
Unless somebody has objections, I would approve it as is. Post the comments, because I don't think we changed anything, right? The only
The read only.
the read only thing. Yeah, that's it. That's right. I have that in my notes. I just didn't see it anymore. All right. Then. Dum 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 dum. Nope. Wrong button. Does that capture everything that was said?
Yes, I think so. Wait. Yeah. You removed. Yeah. This looks good to me.
Yeah.
Awesome. All right, then the next one.
Thanks, everybody.
Thanks, Noah.
All right. So our current headers collections for HTTP client, they perform validation when you enumerate them. Basically, that means that if we get a response back from a server and it has a header in it that is a standard RFC defined header, but it is unparsable for whatever reason, we essentially hide it from the user, just pretend it isn't there. But our reverse proxy needs to be able to forward headers as is without getting any sort of hiding. So our proposal here is to just add a non-validated property to the headers collections. and that would enumerate without any sort of validation or hiding. And we're using structs here for performance.
I think it's probably worth calling out that an alternative that we considered is simply making the existing enumerator return the header values that we considered invalid, but that we had some pushback from security folks that would certainly be a breaking change, and that we would change the handling of those kinds of properties. I think it's more in line with what users expect, in the sense that, you know, like I've seen several issues filed where users were very confused by the fact that when you enumerate the headers, you don't actually get all the headers. You only get the headers that we decided were valid. But the security folks were concerned about the impact of changing this and the security impact of changing this. And so that's why we are proposing new API to give you another way to enumerate the headers that doesn't exclude the ones that we consider invalid.
Yeah, so the question I have is, so today we just drop them on the floor? We don't fill the request?
Yeah, we just pretend they don't exist.
Interesting. And so there's literally no way to access them? Like, that's basically what this thing is. It will give you an ability to at least access the ones we dropped on the floor.
Yeah, exactly. I think the original design was probably for consistency. We have a number of strongly typed properties, and it would be strange if the strongly typed one was null because it could not be parsed, and yet there was a string value in this collection. I'm assuming that was the original intent. So here, at least, you know, to avoid the security concern of no longer validating, we expose this in a new property.
Yeah, I mean,
and it looks like there's an API missing of this, the header string values. That needs to be an IEnumerable of string.
So why do you implement IEnumerator directly on the thing you return?
That is a good question. I would guess that it was simply to make it so the implementation was slightly simpler. I probably wouldn't want that here. It's kind of weird looking.
I mean, is this something where we highly care about perf? I mean, we probably don't want it, like, if it's super inefficient, right? But, like, I mean, basically, naively, what I would think is, instead of doing a property, you would have a method that says get non-validated headers, and it returns an IEnumerable of key value pair of string commas header string values.
Yeah, so perf is not the primary concern, but it is a concern here. We've had feedback from gRPC and YARP that enumerating headers is a little allocatey, and this is one way for us to just slightly reduce the allocations.
But that also means you would, I mean, basically what I try to avoid is, like, what I wouldn't do is I wouldn't tell people that are unhappy with the performance of the headers to just go through this then. Because then you probably want two properties, one for all the existing headers that are valid but with a cheaper enumerator, and instead of having basically just one property that combines them all, right?
Yeah, probably.
Sorry, I didn't catch that.
So basically, my understanding is what Corey just said is that when you enumerate headers today, because it goes to the whole header collection stuff, it's very allocatey, right? But if that is the reason, then I would not push people, instead of doing this, towards the non-validated property, because now they will see more properties than what they have seen in the other one, right? So then I would have two properties. One is basically validated headers, which returns non-validated enumerator, or probably also rename the enumerator at that point, right? And then you have another one which basically gives you the non-validated ones. And so just yeah, don't push people for perf reasons towards accessing non-validated headers, right? That would be bad.
Oh yeah. Sorry if I give the wrong impression here. This is not something that we would say, hey, you want perf, go use this.
Right.
It's more that the people who need this also need perf. It does seem reasonable to also have a validated version that is less allocated, but I think we can propose that API later.
It's more like, since we're introducing a new API here, we may as well make it slightly less shitty in terms of allocation than the existing.
Yeah, that's fair. I mean, I need to look, but like I'm not sure we generally do this. Where I mean, we have done it certainly in some areas, but I don't know exactly where. Because it is a bit concerning that you implement all things on one thing, and the question is, what happens if you walk over this guy now? Do you have
So-
weird
Yeah, I
state
think my
issues?
preference would be to split the IEnumerator implementation into a separate struct.
Yeah, I think the
So-
nested types with structs is fine. It's just unfortunate if you would have two of them, but it's probably better than having just them all mushed together in one.
So we should have a struct non-valid enumerable that implements IEnumerable of key value pair of string comma header values, and its get enumerator returns the struct non-validated enumerator, and it's in terms of allocation. If you do for each over that, you will not be allocating anyway, so it's fine.
Yeah.
Right?
Probably what I would do is I would probably have the enumerable would be a nested type of HTTP headers, and then I would have the enumerator just be a nested type under the non-validated one, and just call it enumerator, right? Similar to what we do with list of t, right? List of t just has one top level type enumerator, right? And that's the pattern we usually have. And so basically you have two nested types rather than
Yeah, I think that's fine.
two types directly nested on HTTP headers.
Well, we'll need 4 types here. There's also the header string values, which is not defined in this API, but
Oh, is that a new
it's
one?
just an IEnumerable of strings.
I thought that's an existing type, no? Is it a new type as well?
Yeah. That is not an existing type. That's an addition which we should talk about.
Okay. What does the headers return today? Doesn't it also have some sort of representation for the comma separated headers?
So the existing API, so HTTP headers itself, the class, implements IEnumerable of key value pair of string comma IEnumerable of string.
Oh, great. I see.
Which is why the idea here is that the header string values, it's very common. Most headers have a single value, right?
Right.
Some have multiple, but by far the common case is single string value. And so the header string values struct, which is not defined here, and I wish we should spell out what it is, but it's basically it's either a string or an IEnumerable string, and therefore if it's a single string value, you don't have to have the overhead of allocating an IEnumerable of string and then enumerating it.
Yeah, that makes sense. I mean, maybe I'm wrong, but I swear to God, I have seen something like this in ASP.NET Core before.
Well, we do this for the collections types, right?
Yeah, they have. I mean, I think they have some type that is, I believe, is struct over the values themselves. I don't think they generally represent everything as IEnumerable of string comma string. Sorry, of IEnumerable of string for the header values. They have a type already for this, but it's
I
probably in
wouldn't
the
be
wrong
surprised.
layer, right? So it's probably like in ASP.NET Core somewhere. So that might be unfortunate. But yeah.
We are speculating a little bit that the perf benefit of not allocating those IEnumerable objects for single valued headers is worthwhile. I don't think we have enough data to know that that's actually worthwhile, but it seems like an easy win, which is why we have defined it that way.
Yeah, I mean, it totally makes total sense. I mean, it's a common pattern we have seen in other places where people have the specialized collection for just one item, right? Because it's super common. So I wouldn't be shocked if that's actually true. And to me, it's kind of just sad to, like, if we have this duplication all over the place where we have this concept encoded multiple times in different layers of the stack, right? That seems generally unfortunate. But so we should just make sure we don't already have something like that we could just repurpose for this. But yeah, there might be some issues with just either it's in the wrong namespace or it's in an assembly that is too high level. I mean, we could probably solve that by just type forwarding that guy down.
Well, these structs would be calling into internals of the HTTP client specific class, so it's not something we could reasonably share anyway.
Yeah, I guess. I mean, it depends on what all the existing stuff works, right? But
I mean, I don't think the struct itself is going to do that. The struct itself is basically just a placeholder for either a string or an enumerable.
Right.
The enumerable that it holds is in fact going to call back into the HP headers class, a bunch of stuff to actually do the enumeration. But I don't think the struct itself is novel in any way.
So the original proposal, or maybe there was a variant of it, was also instead of just calling it a non-validated property, it would be something like a method get as non-validated or something like that. We kind of landed on the property, but I don't think anyone was particularly in love with either of them.
So what exactly non-validated means here? I mean, like, is it invalid headers or?
So say you get a date header from the server and we can't parse it as a date. Currently, we just throw the header away and pretend it never came to us. This would show the original header that had a nonsensical value.
So for us, it's kind of invalid, or for us, it's kind of like it's valid, but we cannot do anything with it.
Yeah, I mean, it means that we didn't fill in the strongly typed date property, essentially.
Yeah, this is the thing to give more context on this.
Mm-hmm.
The way that people usually, so first of all, HP headers is the base class. Then there are three types that are derived from this: HP request headers, HP response headers, and HP content headers, which are used on both request and response. But just to focus specifically on HP response headers for a second, we get an HP response back from the server. It has a bunch of headers. The HP response headers class itself has a bunch of strongly typed fields on it, like server, date, content type, via, and these are all headers that are defined as part of the HTTP spec. And what we do is we try to parse all of those and give you a strongly typed friendly representation of this. So instead of giving you the, canonical UTC string for date, we parse the date and give you back a friendly date time value when you access the date property on HP response headers. So, but there's also a way, instead of going through those, and so obviously, if you give us an invalid date or a server string that we can't parse or a content type that is improperly formatted, we can't give you a strongly typed representation of that, right? So what we simply do is we throw that away and we don't give you any value for that, as if the header wasn't even present, if you access those strongly typed properties. But there's also basically another set of APIs or another way to access the headers that is untyped, which is you can basically enumerate. There's also like a try get value function, but let's ignore that for a second. You can also enumerate HTTP headers. HTTP headers, and therefore HTTP request and response headers, derives from IEnumerable of key value pair of string, comma, IEnumerable of string. And therefore you can simply enumerate that thing and get all the raw text values of the headers. You will see, here's the content type, and here's the raw string for the content type value. You will see here's the server, and if there are, and again, HTTP allows headers to have multiple values. So if there's a header that has multiple values, we will give you an enumerable that has multiple values in it, and you'll have to go consume that. But what we don't do today is, even when you access these properties, when you access the headers in an untyped way, and we return them to you as just a bunch of raw strings, even then, we do not return to you the headers that failed our validation when we tried to parse them to expose them as strongly typed properties. This is arguably a bug. Well, no, that's overstating it. I think this is a flaw in the design, which is to say that if you are asking for all the header values in a raw way, you probably want all the header values in a raw way, but we don't actually give you that. We give you all the header values all the raw header values, except the ones that we decided were invalid because we couldn't parse them into a strongly typed version of the value. Does that make sense?
Yeah. Yeah, I was just trying to understand about the word validate. I mean, like, the term itself, is it just internal for us? I mean, like, just the way that we work, or this is kind of like, can be something like not parsed header or something like this?
It is all based on the definition of what are acceptable values for these headers in the RFC, right? So the RFC says every response should include a date header. The date should be formatted in this particular thing, UTC time, in this format, blah, 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 right?
Mm-hmm. Yeah.
And the vast majority of servers actually do that for historical or other stupid reasons, because HTTP lets people do anything you want and people do anything under the sun. Some servers occasionally provide, or some clients occasionally provide values, because on the wire it's just a string, right? And
right.
So occasionally some servers cough up a value that does not strictly correspond to what the RFC says that the format of this header value should be. And so in that case, we say this is not a valid value. That's what invalid means to us. Does that make sense?
Yes, but I'm just questioning about, like, is this clear for users? I mean, why they see like in non-validated or something, they will understand that?
No, I don't think it's clear to users at all.
Okay.
Like, I think that
So
I've seen several issues. I mean, I don't want to overstate this. It's not like a flood, but there have certainly been issues filed that say, I'm trying to enumerate my headers and I'm not getting one, even though I do a Wireshark trace and I see it's on the wire. And we have to tell them, well, your server is sending something slightly off, slightly invalid, right?
yeah.
And the server may be, in some cases, the server is just kind of slightly out of whack. In other cases, the server is doing something completely wacky, but the client and the server have already agreed to it, and so it doesn't bother them, and they're just trying to get the header value back. So from a user point of view, I think this is incredibly confusing, but it is what it is. Again, my preference would be simply to say the existing behavior where it's fine that when you access it through strongly typed properties that we reject like proper values that we can't parse, because honestly there's nothing else we can do. And that also makes sense. Like, if you give us a value that we're expecting to be a date or that we're expecting to be a content type, text/JSON or something like that, and we can't parse it. Well, the whole point of having the strongly typed API is to give you a nicely formatted, parsed version of this. And if parsing fails, then we're not going to give you one of those. But when you access the headers in a, for lack of a better term, weakly typed way, when you access them like, say, give me all the headers and give me all their values, the fact that we do not return invalid values, to me, is just it's a design flaw. And if we were doing this from scratch, I don't think we'd have this non-validated property at all. I think we would literally just make the weakly typed enumeration give you back all the values. The only reason we have decided that we are pursuing a different approach is because we ran that by the security folks and they said, nah, we're not super comfortable with that.
Right. Okay. So the security folks are not okay even if we provide this with like config switch or something like this?
Sorry, I didn't catch that.
I mean, you saying that today, while they request the list, I mean, of the headers, we just drop the invalid or not validated ones, while you're saying that this is kind of like not good design. I mean, but this is the way that it works today.
Well,
and the proposal to return, I mean, to fix that, you said that I understood that security folks is not comfortable with that, right?
Yes.
Yeah. So my question is, if we provide something like config switch, I mean, the application can configure and to allow getting this non-validated one while they are requesting the list, instead of providing a new UI for that.
I think they'd probably be fine with that. I think the security concern is that people who are using the API today and are not seeing non-validated headers would start seeing validated headers if we change the behavior of that. If we have it under some sort of configuration option, I think they'd be, from a security point of view, they'd be fine with that. I don't think we really have thought about that approach, in the sense of, I don't know quite how we configure that, but that does sound like an interesting approach.
I have to say I'm skeptical that I would accept that, because it's the same thing with things like, gc.initialize create uninitialized array, right? Where we said we don't want it to be a Boolean that you pass into allocate array, because if you look at the call side, it's not obvious from the call side that you will get an uninitialized array, right? Because you just call create array and you pass in, true, and now that has security implications when you pass in false. And I think that will be similar here, right? So if you have a compat switch, usually the way we think about compat switches is you don't want break people that have updated or that, where the app was rolled forward, right? But then you usually have a design that says if you target the latest version of the platform, then you're opted into the new behavior, right? But if people just create new projects and they now start enumerating their headers and all of a sudden they get, unvalidated headers that they've never gotten before, then I think from a security standpoint, that's the same argument. It's like when you look at the code, it's just not obvious. Like, I think that's...
I wasn't thinking... Well, go ahead, Jared.
Yeah, I mean, like, it's just, I think, even if we had a compat switch, I think they would still say, like, look, if I just review the code, I want to know what's happening there, right? And unless the API changes and somehow you state that you get access to non-validated headers, a global compat switch is not good enough.
Yeah, I agree. When I was thinking more in terms of, like, maybe, you could pass a flag, and when you create the HTTP client, you could pass a flag that says, show me all the headers or something like that.
Right.
So less global thing and something more that you opt into explicitly in code.
Yeah, I think if you do it in code, it might be more viable. The problem there is in ASP.NET, like the obvious cases where you would get to control it, which is HTTP client, usually the code or the person doesn't write the code that does the newing up, right? Because you inject it with DI or something, right? And then there's always this ambient thing that they provide for you, and there's factories, and you may not be able to do that. So I think it is probably the easiest way to say let's have a localized API on headers itself, because that's always reachable. You don't have to do crazy gymnastics to get them. And once you're standing on them, it will be obvious that, well, if you go through that code path, you get unvalidated headers. I mean, that seems... It's unfortunate that we have duplication, but I think it's probably the right way of doing it.
So then it comes back to, we need to duplicate. We need to add some sort of property or method or mechanism to get the enumerable for the thing that gives you all the properties, not just the validated properties. And we want to try and do that in the most intuitive and least intrusive way, and maybe make the perf a little better on the way too.
Yeah, so I guess that would be my next question. So I think we've talked about this header thing multiple times. One of the things that Christoph always wanted us to do somehow was, instead of doing any sort of string allocations, you just get access into the headers directly, right? And basically you get the individual values and keys as spans. But that would be a major undertaking to do that, right? And in a usable fashion. So do you think that what you're adding now with the header string values and the struct-based enumerator is good enough? Or do you think that eventually we will find ourselves doing something like what Christoph suggested, and then we have effectively 3 ways to get access to the headers, right? We have the strongly typed thing, we have the, or 4, I guess, then the weakly typed one, and then we have the weakly typed non-validated one, and then we have the the span-based one.
If we did something along the lines of what Christoph suggested, it would not be HTTP client. It would be a completely new API for HTTP. So I don't think we'd have to worry about multiple properties or whatever on HTTP headers or HTTP client conflicting.
Yeah, I guess I buy that. Yeah.
Have already been copied out of the raw network buffer and have had strings allocated for them. It's really just a question of how we return the string values that we've already allocated.
Yeah.
And as Corey said, like long term, we might want to do something much more aggressive here that returns you direct spans or pointers into existing buffers that would not be HTTP client. The thing I don't have a great answer for is how much like header string values is an optimization to avoid creating IEnumerable of string for single valued headers. The thing I don't have a good answer for is whether that actually matters in practice or not. We just don't have enough data about YARP and the YARP scenarios. It seems like an easy win in the sense of like we know that most headers are single valued, and so why don't we give people an easy way to get back a single valued header without allocating an enumerable? But
well, we actually do have some data that we don't have data that our exact fix here will move the needle, in a way that is significant. But we do have data that these allocations are showing up from gRPC and YARP.
Yeah, I mean, I understand what Jeff is saying. I think it's good to have that data. I think anecdotally, from an API design, I buy this will save perf argument, so the type is justified. It would be good to validate the feature before we ship it, though. But I mean, if somebody would tell me, it would be nice to have non-allocating behavior, and that means special casing the one value case, that seems totally reasonable to me. And honestly, like, even ignoring that case, just from an API usability standpoint, I think header string values is helpful, because if you look at the code already, you have nested generics through the roof, right? And if you now expand header string values into IEnumerable of string everywhere, like now you have like 3 levels nested generics, right? So I think just having a type in the middle that is implementing IEnumerable of string already improves the API. And if that also gives us a perf benefit, then great. But I suspect you will find gains by doing that. I mean, I would be shocked if that would not be the case, but
Yeah, no, I think we will. It's just there's a lot of there's other issues in HTTP client as well, and it's hard to know how much certain things weigh against others.
right. I mean, that's why I think I buy Corey's argument that if we really wanted to be much smarter about allocations, then we probably have to kind of like do more than just some surgery to HTTP client, right? There might be actually re-implementation of it.
Yes. If we, and I don't think we know this yet, but if we need to make significant allocation improvements or perf improvements, I mean, there's certain aspects of the HTTP client design, like, allocating collections for headers.
Right.
We allocate collections for headers on request, on response. We actually allocate 2 because there's also one for the content on either of those. If that overhead is significant enough that we want to try and get rid of it, well, then we're probably talking about an API that's not HTTP client.
Right.
All right. So any objections?
I don't have any. Let me just paste in what I have in terms of notes, because I did fuzz with the APIs a bit we talked about the enumerator and other and splitting that up. So I want to make sure that you're happy with what I have. Let me just write down my thought here really quick. Okay. So basically, I just took the struct. I only made it implement IEnumerable of key value pair, and then I have the nested enumerator that implements the enumeratorth one. And I renamed it to non-validated headers because it makes more sense. I think the type generally doesn't make a lot of difference for people because you will never really use it for anything. You will just immediately for each over it. So I think having a nested type makes sense in my opinion. But that is kind of also a question for you. Do you ever envision adding more members to non-validated headers? Because if you do, then, or in general, like, do you expect people to pass these guys around? Like, do you expect people to write method signatures that take in non-validated headers, for example? Because at that point, it really shouldn't be a nested type. It should be a top-level type like header string values.
We don't really, but
Well, we do have other methods to basically use it like a dictionary. So you can do like get header of string that we might add to this at some later point. If someone would pass it around rather than just doing non-validated dot get header, that I don't know.
Yeah, the dictionary lookup I can totally see, right? I mean, yeah, I think that's probably the very next question somebody will ask you to do, right?
Yeah, I mean, I think that it's likely that we would add that API. We're just not here because we're trying to limit the scope of the PR.
Yeah. Well, then let me suggest a slight tweak to this, which hopefully is not offensive to you. How about this then? I make it a top level type. I call it HTTP headers non-validated, so it groups somewhat nicely with the existing one. And then we just have it like that. And then if you want to add more stuff to it, if people want to write method signatures that take them, it's doable and not a complete wacko scenario.
Yeah, I think it's fine. I would make all of these structs read-only.
I guess that's fair. I think that makes sense.
Including the nested enumerators, right?
Oh, the enumerators. Yeah, that makes sense, I guess. Yeah, when you said all the structs, I'm like, there's only two, and one of them is already. But I forgot about the nested one. All right.
The header string values need some way to return a single string without enumeration, which was in there at some point, but seems to have been lost.
Yeah, I tried to find it, but like here it wasn't listed in the original proposal either.
Yeah, I don't think I ever saw that either. I think the expectation was that you would just for each over it, and you would get the one single value through the enumerator.
Oh, well, maybe that's true. Yeah, I guess that's fine.
Yeah, I mean, it seems like you probably want a constructor on this guy, right? Or two of them, right? One that takes the value and one of them takes the enumerable, right? But
yeah, but that's all internal. So
yeah, those would be internal.
Why would you not make them public? I mean, they're just holding on to data at that point, right?
Possibly. I don't know if we've gone deep enough into implementing these to know if that's how we would want to implement them yet.
I mean,
unless Jeff has done the work there, I haven't looked at the types.
I mean, for things that are generic data holders, I would generally suggest make sure you can construct them, because if you want to write tests, for example, it's just a pain in the ass if you can't construct those things. Because then you have to basically provide your own abstraction that does the same thing that this guy does, and then, well, the perf optimization goes out the window because now I have to replicate that. So unless you have a really strong reason why they shouldn't be public, I would make the constructors public. Like, it seems just a no-brainer.
Well, I mean, the structs are an optimization, right? These implement IEnumerable, so is it something that can't be mocked?
I guess.
Yeah. Yeah, I don't know if we know enough about what the constructors would look like right now to ask for an API for them. Like, what you had there seems reasonable if that's how the implementation shook out, but I just don't know if that's how it will.
Maybe just instead of mocking the API, let me just add a question to the bullet points.
Or it would be fine to say, like, we're also approving these two constructors if you happen to use them.
yeah, I guess that the implementation may not literally have an IEnumerable under the covers. It may just, yeah.
Well, we might have, like list.enumerable or something under the covers, right? So.
Yeah, what you said, that it's basically just an IEnumerable of string anyway. Probably good enough.
Right.
All right,
Okay,
then let's
I'm happy with that.
go down this path. So everybody happy with that outcome?
It's good to me.
Perfect.
All right.
There goes another
so for
hour.
this one, we did the initial API review. Steven came back basically saying he disagreed with some fundamental parts of it. So we're coming back to kind of talk about those, as well as a few things that we noticed just while implementing it. So that API proposal, that API is actually the current approved API. If you want to scroll down, we have kind of the feedback that we saw. There we go. So we initially wanted to create kind of derived exception types, such as connection reset exception and so forth.
Scroll up to the text with the feedback, actually. I think it'd be useful to see that.
Yeah, there were bullet points there. Yeah, so we initially wanted derived exception types like connection reset exception. Stephen, I think I will try to distill his argument against that. For one, type, just type explosion is a worry here. Like we have quite a lot of socket errors, and we probably don't want to create an exception type for all of them. Initially during the API proposal, we agreed that we would only create derived ones for the most common ones that we think people would actually catch. But Stephen is worried about us just adding more and more and more. Also, he's concerned that we would not be able to sufficiently or generically distill socket errors in a way that would prevent a user from still needing to use an exception filter to kind of test for multiple of these exceptions that they would want to handle identically. And one example was in ASP, they're doing certain platform detection, based on just the underlying OS APIs returning slightly different error codes in different circumstances. And the detection that they were doing was at a place that we probably could not make all of it generic. Jeremy kind of came back and filled us in with the recommendation that I guess came from Christoph originally of you should create derived exception types, but Stephen thinks that we should kind of embrace exception filters for this, and we should be okay with that. That perhaps the prior guidance was developed before we had exception filters in the language.
I mean, I need to look it up again. Like, I think there was certainly that aspect to it, but there's also I believe exception filters also have very subtle behavior differences. Not so much for the handler itself, because once the handler is reached, it's the same as the normal catch handler. It's more for the expression you put in the filter, right? Because that runs basically before the exception is caught, logically. And so you have some limitations of what you can do. But it's probably not a big deal, because for the most part it will be something like, well, check for this value, right, and inspect is the an exception of a certain type or something like that, right? So you're not very likely to run like super arbitrary code in the filter. I mean, people do, but it's not the main scenario.
So I mean, the API as approved did include this error code.
Right.
So people with that API would already have the option of having an exception filter.
Right.
So I don't necessarily know if I buy Stephen's argument about specifically that, but I do see the argument against type explosion.
Well, I think his argument was more along the lines of, if you have these specialized types, can I actually write code sufficiently with them, right? Because one thing that I do notice myself all the time is that I find I catch 4 or 5 different exception types, but the handler is basically the same for all of them. And there's not really a convenient way of doing that in C# unless you write a filter, unless you say catch exception, and then the filter is this type, is that type, or is that type, right? So basically his argument, I think, is if you push people that direction, then why do you care what the actual check is that they have to write, right? Because if you compare this type, or you just, basically do a switch on the error code, it's virtually identical at that point, right? And I think that I do buy a little bit, because I guess many people who write networking code, when something doesn't work, it's just like, sorry, can't do this, right? And so the error handling code is probably uniform for a lot of stuff, right? And then it's great when you can actually get these individual errors out of it, but then if one of the common scenarios is just do everything the same, and then you write a filter to do that, then you actually make it harder for people to do that, right? Rather than just catching one exception, right? So I
think that's part of the thinking of why we ended up with the enum instead of a bunch of derived types, is that the common case is something went wrong, right? The network exploded and now you can't talk to your server anymore.
Right.
And you don't really care what the specific error was. But there's certain cases where you may, in fact, want to inspect the error code, not just for logging purposes or diagnostic purposes, but to actually take action in your code itself.
Right.
But that's not the common case.
Yeah, I think
that
yeah.
the way we distilled the errors, I do believe we would see users finding benefit from just catching a concrete exception, while still leaving it open to them if they want to use an exception filter. But I don't really feel strongly that we need the exceptions. Like I have down below, I have a comparison of the old usage and the new usage, and anyone writing sockets code today is already familiar with using exception filters because that's just how you use socket exception. So it's not really going to be a shock to anyone that they have to use them here. Using a derived exception type, I guess, would just be slightly more idiomatic to how most of the other BCL types work.
Yeah, I mean, one thing that is interesting in that it's, I mean, I looked at this code for 5 minutes to figure out what's actually different. But like, it's order, right? But I guess that's already the case anyway, because they can always dispatch top to bottom and the first handler that wins is executed, right? Yeah.
So I think the networking team is fine not doing the derived exceptions. We really just wanted to bring it to this team to make sure that we were okay with sort of relying a little heavier on the exception filters than most of what the BCL does today.
Right.
And in particular, getting rid of the factory create method.
Yeah, so if we did get rid of these, then we would get rid of the factory and we would make the constructor public.
Yeah, I was about to say, how does this actually differ from what we have? It literally would just remove the factory, right?
Yeah, so we're essentially, we would say we don't plan to make derived types, so we don't need the factory anymore.
Right, but that's, so it's basically the difference is mostly in strategy, not in actual API shape then.
Yeah, but at the same time, Jeremy commented on the issue saying, hey, if you want to argue against the derived types, that's fine, but we should probably talk about it and get again in API review to kind of make sure the whole picture still fits, rather than us just choosing to not implement it a couple of the APIs that were approved.
Yeah, I mean, like that's, yeah, I buy that. I mean, I think I've said this in FXCC multiple times. Like, I'm kind of back and forth on the error codes as well. Like, I think by and large, like for some areas it makes sense, right? Networking or IO often has like this very long tail of error cases, right? And I think it's reasonable to use error codes there because it doesn't explode as badly. And then the only downside really is that, it's not, I mean, we think of exception filters as this thing that basically everybody can use and everybody knows how to use, but it's, for most people, it's still a relatively recent feature, right? And so there might be some downside to that, but at the same time, those kind of people are probably also better served with just effectively the catch-all handler anyway, because it's like, well, networking didn't work, exception to string to the log, right? And then you move on with life.
Right.
So in that sense, I don't actually think it's bad to do. I mean, I think having a dedicated new exception type, I think, is useful. And we said last time, like, the expectation is that whatever the underlying error cause is, anyway, will be in the inner exception, right? The socket exception or the whatever
exactly
implementation you have.
So I think it's fine. I think there are cases where people could realistically catch the derived type and have slightly cleaner code for it. But I don't see it as a huge improvement to code readability, and it would let us reduce the number of types that we have.
So the new thing you propose to constructor slightly differently than the old one.
Yeah, so the next bullet point, Stephen called out that all of our existing exception constructors have the message parameter first. So in the new proposal, we just moved the message first. We also added a second constructor without a message so that users can get the default message for an error code.
Yeah, the issue here is we think the common case is actually that you just want to specify an error code and get the standard message associated with that error code. And therefore, the second overload here, you just pass an error code and an optional inner exception. But in cases where you want to provide a custom message, we provide another overload with the string parameter first, which is the common pattern for exception constructors, the string first, etc. And so that it follows the common pattern, but also gives you an easy way to do what we think the common usage of this is.
Yeah, I mean, I can see both arguments. I mean, they both have pros and cons. I mean, to me, the string first is, I don't care that much so long the other thing you put in front of it isn't also a string, right? Because that's really what fucks people up. Like the argument, one of the argument exceptions where the param name and the message got swapped, right? And it's like everybody gets it wrong all the time because, well, muscle memory, right? And code happens to compile, right? But in this case, if you call the method incorrectly, like you will immediately tell because it's like, oh yeah, sorry, the first argument is the error code, not the message. So in that sense, I don't think it's a biggie.
I don't think it's a big deal either.
I mean, the only other thing is like you also have this
convention
conflict.
Is nice.
Sorry, what? The convention.
I just think conforming to the existing convention is
right.
Worthwhile.
Well, the problem with that, this is why it's hard, right? Because we have basically multiple conflicting guidances, right? One of them is don't swap argument positions, right? That's one guidance, which you do here, right? Because if you go from one to the other, now error code moves by one spot, right? So that's we already said we don't want to do that either. And then the other one is, be consistent across types, right? So yeah, pick your poison, right? They're both have pros and cons. Personally, I can go with either one of them. Like, I don't think it's if Steven feels strongly about it, like, I have no problems with that. I just want to point out that, with these things, it's kind of like whack-a-mole, right? You can make one thing work, but then another thing isn't, right? So it's like, pick the one you don't want to have work.
Yeah, I don't know if Steven felt strongly about it or not. I certainly would prefer one constructor. I would prefer to go against the convention, but yeah, I wouldn't mind if we had the two weird constructors. It wouldn't be the first time in our networking APIs that we have that.
Yeah. All right, so then unless people have any sort of concerns, that's just what it is.
The other major change that we have is we had defined these to have address in use and invalid address, and during review I realized that none of the APIs throwing this have anything called address on them. We use endpoint. So just a suggestion that we rename these to endpoint in use and invalid endpoint.
I would probably suggest to just swap the second one. Like endpoint in use and endpoint invalid seems nicer.
Maybe. I mean, they're not really intended to be grouped together, I guess. So it doesn't really bug me, but
Yeah, I mean, to me, it's like I just see the enum list, and it seems weird that these things switch positions. But like, I don't have a strong opinion. It's just usually like pick your poison, right? There's like you go with prefix or suffixes, right? But mixing them seems weird.
well,
And
we
you-
could also call it something like endpoint not supported. Then it sounds grammatically correct, and we have that nice lineup of endpoint being the prefix.
Works for me.
Yeah, the socket enum values actually start with address, which is interesting. They're address family not supported and address not available, which are slightly different things. And I don't think I'm not sure. I don't know if we want endpoint not supported or endpoint. I don't know.
Yeah, I mean that's my other question. It's like it's the only one where you have two underlying causes mapped to the same value. Like, do you think that's confusing? Maybe. Do you ever see cases where people would differentiate them, or would you then just say, tough luck, you have to check in exception for a socket exception, then you ask the socket exception's error property if you want to know?
I think that's what we tell them.
Yeah, I feel like this is probably actually kind of rare error code. I actually wouldn't mind just getting rid of this network error, unless Jeff, you think it's more common.
No, I think it's fairly uncommon too. I'd be happy to just kill it.
So you mean the endpoint?
Well, it's gonna be like in weird situations where, like you're trying to connect to an IPv6 host, but you're running on a box that doesn't have IPv6, which is extremely uncommon, and is if you've gotten that far and you're trying to run it, then you've probably not done your job well. You know what I mean? So these are errors that indicate something you badly miscalculated, and I'm not sure it's worth making them a first-class thing.
So then basically the third enum member, endpoint invalid or invalid endpoint, would disappear.
Yep.
All right, that seems easy. So we are now down to unknown, endpoint in use, host not found, connection refused, connection aborted, connection reset, and operation aborted.
Yep. And we added operation aborted here. It was not in the last API review.
Yeah, so what's the difference between connection aborted and operation aborted?
Connection aborted essentially means that some TCP issue happened, like resending lost packets failed for some reason. And operation aborted means the user canceled the operation somehow, either by closing the socket or asking for a individual op to be canceled.
Yeah. Connection aborted means that the TCP stack decided something went wrong and decided to kill the connection.
Mm-hmm.
Operation aborted means the user did something that caused the connection to be killed. In typical use, we actually we often will swallow operation aborted and convert it to a operation canceled exception.
Right. That was Boston.
Because that's the most common case in which we get that sort of thing.
Right.
But there are other cases where we don't map it to something else.
Gotcha. Yeah, that makes sense. All right, then. That was easy. I mean, like, it's nuanced, right? I mean, that's why having a chat is, I think, good. So is there anything else we should be looking at? Otherwise, I'd call it early because I don't think we have a lot of people around. I mean, I think Levi is now on the call.
Yes, hello.
Should we look at something in the last 20 minutes?
Some of my ones are pretty
yeah.
small.
Okay, let's do that.
Which ones do you have in mind,
Unless
Tanner?
Levi had something.
No, the very first one there was simple, but we should do Tanner's. They've been around longer, I think.
Yeah, that one should be simple. The simplest is probably the consider expanding one. And expose the new call convention one.
See, your wording
Those are
always
probably
makes
the
me scared because consider expanding usually results in like, is another 50-100 types we should add for this esoteric processor set.
No, I actually explicitly called out that this set is small. If we want to do the more complex option of expanding vector 128 and 256, that's potentially hundreds of new APIs.
Okay, cool.
Yeah. Well, let's just make this one a little easier.
Yeah. So this is basically, we have vector of t today. In the runtime itself, we are actually if-defing to simulate vector of inint and inuint in various places. This is just proposing we expand the APIs to officially support them. And this is the exact set of APIs we would need to add.
For the first two as methods, as vector int pointer, as vector uint pointer, would they actually have int pointer, uint pointer, or would they be called nint, nuint for the method names?
I called that out just below as a potential consideration. So what we've done historically and in the guidelines is that rather than using a language keyword, we explicitly use the name of the type as exists in system. So we use int32 rather than int, we use int64 rather than long. Technically, the type is int pointer, which is why I used it here, even though the language keyword is inint. However, given that some people have strong opinions of int putter specifically being for handles and pointers rather than inint, which is for native integers, I think it might be acceptable to allow in special case the rule for as vector capital N, capital I, lowercase n, t. But I didn't have a strong preference on that.
I mean, that is something we should just basically decide what the how do we call this, the long name for the keyword is basically, right?
Yeah.
And I think NINT works for me with capital N and I. And then same with NUNT, right? Similar to how int32 and uint32 look like, just prefix with n without the bitness.
Yeah.
I mean, I guess there is a difference in behavior, right? Because if you call, like basically we mark these members as the return type really is vector nin, not vector in PDR, right? Because if you type it as var in C#, you still get nin back, right?
Due to how the runtime works and how the language works, there will be an identity conversion between the two. They are actually the same underlying type, and so there isn't actually a big difference from the perspective of these APIs.
No, I get that it's the same underlying type, but like if you say var x equals as vector in PTR, and I inspect what x is, it will be typed as vector as nin, right? Because there's this attribute on as vector in PTR that says I'm really giving you a nin, not an NPDR, right? So
there will be a minor difference in the default behavior when indexing the actual underlying elements as far as the language is concerned.
Right. And yeah, that's probably consistency issues where did we actually put the attribute on any of the existing APIs? Or have we largely not done that?
We've not converted any existing APIs yet.
Then I think honestly I would just call it as vector nint and as vector uint.
Okay, I'm fine with that.
I mean that seems to be worthwhile pointing out here. We should use n int and n uint as the long or as the non-keyword type names for APIs that return or that have to specify, that have to refer to.
I'm glad, Tanner, that my stupid tricks and ask utility are the things that that spawned this conversation. Those unholy things that never should have been done, but it is what it is.
It's performant, and there's other places where this will be useful as well.
Yeah. One of the things that we were actually looking at internally for a vector of new int was you have an object array and you want to know if any of them are null. Well, you can unsafely reinterpret cast it as a vector of new int because, well, if it doesn't matter if the GC doesn't track the references because non-null is going to become non-null and null will become null, so whatever. So we were considering that as optimizations.
So Tanner, is this the only thing where we would add this?
Your screen is, hold on, Teams is messed up.
No, I see it too.
Okay. Immo's screen is messed up.
What is my screen doing wrong again?
It's all pixelated.
Oh, great.
Like I can't read anything.
I blame Teams on this. Like I mean, it works great in OBS, so clearly it's Teams choking on my display driver probably. So I guess my question is,
which issue are you on?
So I'm still looking at the vector one, right? So my question is,
okay.
you only identified like 6 methods, right? Realistically, 6 method groups, where we would add this on the non-generic vector type. Are these really all the ones, or were there ones you excluded?
Those are the existing generic functions that would be expanded to support the new operations. There's potential for other operations like addition and stuff, but those were explicitly left out because they aren't currently needed and they aren't currently used anywhere in the runtime. And some of them would automatically light up with. Sorry. These are the non-generic versions. The existing generic functions would automatically be expanded. These are the cases where the type is explicitly called out somewhere. So the existing vector of t operator plus, for example, would naturally have to be expanded to support this as well. Gotcha. But there's no new API for that.
Gotcha. So basically what I was just getting at is like, because vector was basically, we hadn't selected where certain operations made sense for certain combinations of types. And I was just wondering whether there's any particular ones you left out, but I also haven't looked at the vector type in a long time, but I take your word for it.
For the non-generic APIs, that is the APIs which explicitly use a concrete type as one of the inputs or outputs. This should be the full set.
Yeah, so like, all the ones that are generic you get for free, right? Bitwise and bitwise or.
Yeah.
Okay, that makes sense. All right, then. Let's approve this puppy. All right. Let me try sharing my screen again. Maybe we're in luck.
That's better.
Okay, cool. Then this one here.
Yep. So we exposed the suppress GC transition attribute. However, due to the way function pointers are encoded, you cannot use attributes on function pointers. The proposal to handle that is to expose a new calling convention type, which matches the general layout and convention of the other calling convention types, and what the C# compiler will support for the function pointer syntax, so that you can explicitly, for example, do delegate star, open square bracket, standard call, comma, suppress GC transition, close square bracket. which will specify that the calling convention is actually standard call and that the runtime should suppress the GC transition when invoking the method.
Didn't we already approve something like this? This looks very familiar.
We approved the actual suppress GC transition attribute, which is used for everything that's not function pointers.
No, I mean, like, didn't we recently add another calling convention? Because I'm pretty sure we recently had another call conv type that we added. Or at least we discussed it. Maybe that was the thing.
I think we discussed it in the context of reviewing the function pointer, the related function pointer types.
Yeah, I mean, this makes sense. I mean, this is kind of, as you said, it follows the existing thing. Where did we put the suppressed GC transition thing? Is there? Oh, there's a calling convention struct probably somewhere, right? Is there not?
So this isn't an actual calling convention per se, and it wouldn't be as far as I'm aware, but I could double check with Jan and Aaron. We wouldn't also be updating the bit flags with this bit. Instead, the way it works is that as far as the bit flags work, it will be marked with the new extensibility bit, which I think is just called unmanaged. And then if the unmanaged bit is set, you have to look for the corresponding mod opt that contains these types. So call conv suppress GC transition to fully interpret it.
I see. So why do we don't prefix it with call conv? Is it not then the same as all the other mod ops that we have in runtime services, like is blah blah blah?
It's prefixed with call conv because the language needs to know which things are valid to use as function pointer modifiers. So it does that by looking in system runtime compiler services for the core lib assembly, which is the assembly that contains object and has no dependencies. And it looks for anything prefixed with call conv. And then it strips that call conv and allows everything after the call conv as the actual usage in the language.
Do we have an example of what this looks like in the language? Like, I have a hard time visualizing this. Like, where do you put these guys?
So it would be delegate star unmanaged standard. I posted in the chat there, and I'll also post it on YouTube for convenience.
Yes, that makes sense with the conventions we already have for unmanaged function pointers. Wow. Okay.
Okay. I'm amazed that this is C#, but okay. I guess this is what it is.
Function pointers are hard to define due to limitations in IL and other things. And they're not meant to be pretty. They're unsafe.
Yeah, so then I guess that makes sense. I mean, at that point, like... My only question now is, like, you said, like, the compiler has a hard requirement that this starts with call conv. Like, is there any work that happens in the time frame right now? Like, what happens if this feature falls through? Do we then have that type that the compiler doesn't actually use?
Well, so this isn't for .NET 5, this is .NET 6.
Right, but if I approve it now and somebody then checks it in and then later on we decide that's not the path we want to go through, then we then have like that type basically?
We won't check it in without the corresponding JIT support also being checked in.
So we'll find out then.
Yeah, there's no language support required. The language doesn't do anything other than just look for these types. There is JIT work required to recognize this particular mod opt, and that's why it's not for .NET 5.
Yeah. Yeah, I believe right now we're not looking at anything that's in 5.0. I think we're way past that.
Yep.
Everything now is future or none. All right. Oh, this is Levar's favorite type.
The other one might be easier. The general
Yeah.
purpose CRC32.
Yeah, the other one's easier.
All right.
So, certain platforms have hardware acceleration for cyclic redundancy checks. We are proposing exposing under bit operations a set of helper methods that will call the underlying platform algorithm when available, and which will use a fixed what's the word? Fixed. It's not seed. A fixed value when doing the algorithm, rather than allowing an arbitrary one to be provided.
So what is the, I mean, I think we talked about CRC before in the context of like bit operations is the type that would expose things that would always work, right? And they would in turn be implemented using hardware intrinsics where applicable, and then maybe even have an IL fallback if none of the intrinsics apply, right?
Right.
This one probably doesn't have a fallback because it's so basic that everybody has it already.
No, it would still provide a fallback because hardware that's like all hardware that's 10 years old should have it, but hardware that's like 14 years old might not.
And that hardware still runs Win 7.
We technically have to support it, yeah.
So then, yeah, that makes sense. And
Because Linux, for example.
And there's no, I mean, isn't CRC usually for a stream of bytes?
So these functions are built, these functions are iterative. So you would end up doing, you basically pass the output in as the CRC value of the next call.
Oh, I see. So you'll basically loop yourself.
Yeah. This is essentially the CRC32 primitive that you would use to build a function that operates over bytes.
Gotcha.
In particular, the polynomial, that's the word, the polynomial used by the function on both x86 and ARM is 0x 1e dc 6f 41.
I was about to say
ARM also provides a variant. So that specific polynomial, I think, is the CRC32R or C polynomial. There's also one that ARM uses, which is 04C11DB7, which it provides as a separate instruction. There was a question on if we should provide a variant that accepts a polynomial in which the JIT could then constant fold if that polynomial matched one of the hardware accelerated ones. And my initial thinking was that would be out of scope, and we could look at providing that as a separate API in the future if needed.
Yeah. So I mean, what is, by the way, when you start a CRC, you pass in 0?
Yes, that's normal, I believe.
I mean, in general, I would say I don't know enough about CRC checking whether these, selecting the polynomial is a key scenario. I would guess no, maybe.
It is for some scenarios. For example, zlib uses a different default polynomial than is hardware accelerated. So in some scenarios, you may want to provide a polynomial that's different from the hardware accelerated version, so you can match those algorithms. But I think it would be fine to expose these ones, document that the polynomial is this, and then later look at exposing versions that take int polynomial as a third value.
Yeah. I think
unless we wanted to expose those variants as the exclusive and then do the checking for if the polynomial is a constant and it matches this, accelerate.
Right. Yeah, seems reasonable. So then let's start with these overloads and then add the other ones later.
And I posted the polynomial in chat if you want to include that in the approval.
I think I'm fine. Thanks. Like, yeah, I mean, we should document the one that we are using. I suppose the ones you're using are somewhat standardized, right? It's not just happenstance, but what's happened to be accelerated, right?
Right. The hardware explicitly documents the polynomial as that.
All right. Then I think we're good with this one as well, and then I think we're out of time, right? Yep. We did good.
Yep. And next time we can do that very first one. That'll be very easy.
Sounds good. Then have a great, yeah, I guess next time, by the way, is tomorrow, but
Perfect.
Is the conference happening tomorrow as well, Levi? Do you know?
Yes, it's the entire week.
So that means Jeremy is not going to come tomorrow either, then, right?
Well, it depends on which talks he wanted to watch. The conference is a series of talks, and people often just go to the ones that interest them and do other things. That's actually one of the problems with it being a virtual conference this year. Most of the time, the conference is meant for networking rather than just going to the talks. So
yeah,
it is what it is.
That is the nature. I mean, the good news is it's going to be the same thing for the whole next year. So,
hooray!
Yeah, isn't it nice to have somebody who's optimistic? All right, then I see some of you hopefully tomorrow.
Yep. Bye.
All right. Bye bye.